Hi, welcome to the third video in my proof by induction differentiation series. Again, with this video, we're going to go through a problem where we're kind of going in blind. I haven't yet done this problem, but it's just to prove the point that as long as you follow this algorithm, it's going to be kind of just looking for the target, doing some differentiation. That's the hard part. So let's crack straight into it. So first of all, let's have a look at our base case. So base case, which is n equals 1. So we've got the derivative of x minus 1 times etx over 3. Well, this is a product rule, so the derivative of the first function, which is 1, multiplied by the second function, which is etx over 3, plus, now we're going to differentiate the first function times by this, differentiate the second function times by the first function. So we're going to get a third etx over 3 multiplied by x minus 1. Next, let's pull out a factor of etx over 3. Because if you notice, there's a factor of etx over 3 here. We're going to be left with 1 plus x minus 1 over 3, giving us etx over 3 times what's going to be 3 plus x minus 1 over 3. And well, if you put 1 into here, clearly we're going to get exactly the same thing. So, true for base case. Next, let's have a go at our assumption. So assume true for n equals k, i.e. we have that the kth derivative of, well, x minus 1 etx over 3 is equal to, and well, we're just going to put k into here. So we've got 3k plus x minus 1 over 3 to the k multiplied by etx over 3. Next, we're going to do our consideration. And our consideration, we're going to just straight away try go into differentiating our assumption. That's pretty much what a consideration is. So consider n equals k plus 1, i.e. we're doing the derivative of the kth derivative, or in other words, the derivative of our assumption. Now, if you're unsure on why this is true, go into my previous videos and have a look at them. It's going to give a lot better explanation than I'll give in this video, because this video is more to look at a model solution. So we're doing derivative of our assumption, because the kth derivative is exactly this, according to our assumption. Alright, so differentiating this, so we do the derivative of the first function. That is just 1 over 3 to the k. Multiplied by the second function, which is etx over 3. Plus, and now we differentiate the second function, which is 1 over 3 etx over 3. And we multiply by the first function. Okay, now at this point, it'll be helpful for us to write down our target so we know what we're looking for. So our target, well, we're putting k plus 1 into this original expression. So target is 3 times k plus 1 plus x minus 1 over 3 to the k plus 1 etx over 3. So first of all, we want this factor of etx over 3 on the outside. So let's do that first. That's quite easy. We're going to be left with 1 over 3 to the k plus 1 over 3 times 3k plus x minus 1 over 3 to the k multiplied by etx over 3. Okay, so we've got the etx over 3. Next, we need one common fraction where the bottom is going to be 3 to the k plus 1. So we're going to have 3 over 3 to the k plus 1, where I've just multiplied top and bottom by 3 to get that denominator. This one, well, actually, it's going to have a denominator of 3 to k plus 1 anyway. So we're going to be left with this And well, combining these two fractions, grouping up the 3's, well, we need an x minus 1, which we've got, but now we need a 3 times k plus 1. So we've got 3 times 1 plus k, where I've taken a 3 out of here, I've taken a 3 out of here, plus x minus 1. I haven't touched the x minus 1 because it's already in the desired form that we're after. That leaves us with this, which is exactly what we were after. This is exactly our target. I hope this video has been helpful. If you're still unsure on how this works, go back to my first video and rewatch that. There's a lot better of an explanation for it. This is just a more tricky example where we can apply the algorithm I introduced there, and then we can see exactly how it works. Thanks for watching.